So we're going to talk about multiplying rational numbers. Now, but the first thing that we need to understand is what is a rational number. We need to know the definition, okay? So basically, if you look on my board, any number that can be written in the form of a over b or a quotient of two integers is called a rational number, as long as b, which is the denominator, is not equal to 0. So basically, to recap it, a rational number is a number that can be written as a ratio of two integers as long as the denominator is not equal to 0. And I'll give you some example. For example, if you have 5, 5 is a rational number. Why? Because 5 can be written as 5 over 1, a over b. So this is a rational number. 1/2 is a rational number because this is 1 over 2. Again, a quotient is also called a division or a ratio. So anytime you can write a number as a division of two numbers, as long as the denominator is not equal to 0, is called a rational number. An example, -3 is a rational number because -3 is a quotient of what? -3 and 1. These are both integers, okay? Integers encompass positive and negative numbers. So an integer can also be called a rational number, okay? And also you also have 0.5. So 0.5 is also a rational number because 0.5 is basically 5 over 10, okay? So if you have a dot here, this is the tens place. So every time you move the decimal from one place, you always divide the number by 10. So if I have 0.05, this will be 5 over 100 because I'm moving one place, two place. This is the tens place. This is the hundredth place. So every time you move the decimal one place to the right, you add a 0 and that becomes a quotient, okay? So 0.05 is also a rational number, okay? Now here's the thing. When you have rational number, you always want to make sure you simplify them, okay? You don't leave 0.5 as 5 over 10. Here's what you do. You can break down 5 over 10, right? So 0.5 is basically 5 over 10. Now, we don't leave this like this. We have to simplify. Simplify. Meaning, the meaning of simplifying is you want to put these terms in its lowest form, okay? So, now how do you do that? You need to find a number that both divides 10 and 5 at the same time. And we call that number the GCF. The GCF, or the greatest common factor. Greatest common factor, okay? So basically, when you have 5 over 10, what goes into 5, that goes into 10? 5. So this is how you break it down. So let's break that down, okay? So I'm going to rewrite this. 5 would just be 5 times 1. And 10 will be 5 times 2. And now you have the same term on the numerator, and the denominator, you can just cancel it out. So this becomes 1 over 2. So 5 over 10 is 1 over 2. Now the next thing we're going to learn is how do you multiply rational numbers, okay? This is pretty easy if you pay attention. So let's get to that. So first I'm going to give you the general formula, and then we're going to work on some examples. So a over b times c over d equals a times c over b over d. So basically, when you multiply rational numbers, you just multiply across, okay? The numerators are going to be multiplied together and the denominators as well. So this becomes a times c over b times d. Let me give you an example. If I have 1 over 2 times 3 over 5, this becomes 1 times 3 over 2 times 5, which is basically 3 over 10, okay? So 1/2 over times 3 over 5 is 3/10. Now, there's one thing, when you multiply rational numbers, you always have to make sure you have them in their simplest form. Basically, if I'm here, okay, I want to see if 3 and 10 have a GCF, a greatest common factor. They don't, because there's no number that divides 3 and 10, and the only number that goes into 10 that goes into 3 is 1. So I'm going to stop here. Okay, but then we have another case. Let's assume that I have 3 over 4, right, times 7 over 9. All right, so to multiply these numbers, we're going to do 3 times 7, right, which is 21, and then 4 times 9, and that is 36. So when you get here, okay, most people will multiply and then try to find the GCF, which is the greatest common factor. So what goes into 21, that goes into 36. If you know your multiplication table, you know that 3 goes into 21 and 3 also goes into 36. So basically, if you divide it by 3, you get a 7. And if you divide it by 3, you get a 12, and that gives you 7 over 12. But here's the problem. I don't like doing this way because it gets harder. Because basically, you're multiplying these numbers and then you're going to try to simplify them. So is there an easier way to do this? Yes, there is. So we're going to get to that. So if I have 3 over 4 times 7 over 9, so what I'm trying to do here is this. I know that there can be a connection between 3 and 9. So I'm going to try to break down 9 in its prime factors, okay, the prime factors. So basically, you're going to find the lowest terms that goes into 9. So these stay the same. I have 3 over 4, and then that becomes 7 over 3 times 3, because I know that 3 times 3 is 9. Now, I can simplify this, okay? I don't have to multiply them first. I can put all of them on the same line. So this is going to be turned into 3 times 7 over 4 times 3 times 3. Now I can cancel this out, and I'm left with 7 over 4 times 3, which is 12. So this is a simpler way of simplifying fractions once you multiply them, okay? So multiplying rational numbers, you always want to multiply them and then trying to find a way to simplify them, okay? So this is the best way to do it. I'll give you one more example, and then we're going to end this lecture. So assume that I have 4 over 10 times, let's say, 25 over 16. Now the tendency for people is to multiply these two and then simplify them. That would be hard, that would be too much work. So what I'm going to try to do is this. I'm going to see if there's any connection between 4 and 16, and then 10 and 25. Or if you don't want to do that, just break this down into their prime factors, okay? But I know that there's a connection between 4 and 16, so I'm going to leave 4 as 4. But I'm going to try to break down 10 into what? 5 times 2, okay? I'm going to do the same thing here. 25 will be 5 times 5, and 16 will be 4 times 4. Now, this can all go on the same line because we are multiplying across. So this is 4 times 5 times 5 over 5 times 2 times 4 times 4. You can cancel the 4s. You can cancel 1 5, and you are left with 5 over 2 times 4, which is basically 5 over 8, okay? And this is basically how to multiply rational numbers and then simplify them. All right? Thank you, and I'll see you next time.